check this out. These are all of the gold-plated ceramic IC chips my friend Johnny has sent me to process for him. And with gold at over $4,000 a troy ounce right now, this is a veritable king's ransom in gold waiting to be recovered. So I think it's about time I got started on this stuff. Well, hello scrappers, Mike here. Welcome back to my channel. And check this out. Check this out. These are all of the gold-plated ceramic IC chips my friend Johnny has sent me to process for him. And with gold at over $4,000 a troy ounce right now, this is a veritable king's ransom in gold waiting to be recovered. So I think it's about time I got started on this stuff. I'll give you a close-up look at what we're dealing with here. Whole bunch of dual inline chips over here, EPROMs and other stuff, RAM chips. Over here, well, all kinds of just luscious chips, dual inline, and these sorts of chips here. Just all kinds of stuff. And over here, wow, does this make your mouth water or what? This is amazing. It's an amazing collection. In case you are not familiar with my friend Johnny, I'd be surprised if you've been watching my channel because I've been doing a lot of jobs for him lately. He lives in Finland, and he disassembles a lot of old European phone equipment by like Nokia and Ericsson and other European companies. Old stuff, as you can tell by what we've got here. So it's about time to start processing this stuff for Johnny. Now there is just a huge amount of material here. We'll weigh it in a little bit and figure out just how much we've got here. But there's just a huge amount of material. I have never done such a large amount of ceramic gold-plated ICs before. So I think I'm going to have to try and change up my methods here a little bit to try and get all this done. But we'll talk about that a little bit more later. We've also got different types of ICs, which are possibly going to require different types of processing. So we'll talk about that later too. But anyway you slice it, there's too much here for me to do all at once. So this will be in multiple batches, I'm sure. So this is going to turn out to be multiple videos, many multiple videos. We'll see. I'll try not to be too repetitive though. All right, let me get my scale out and let's weigh all this stuff and see just how much Johnny has sent me. Oh, and by the way, last time I talked to him, he said he was going to bring me even more. So we'll see if it arrives soon enough for me to add it to this batch or if we're going to do it separately in the future. We'll find out. Anyway, let me get my scale and we'll weigh this stuff. All right, we're going to start out on the kilogram scale here. So, and yes, Richard, I know I'm weighing the boxes, but trust me, they are just a tiny fraction of the total weight. These things are heavy. 7 kilos, 806 grams, minus whatever the boxes weigh, or 17.2 pounds. All right, so this is a lot of stuff. So let me lay out some of the different types of chips here and talk about where the gold is on them and how I'm going to process them. So let's talk about a few things before I get started. I know some of you, too much talk. Well, this isn't TikTok. If you want things done in 30 seconds, go to TikTok. We're going to talk about this a little bit before I get started. We've got a lot of different types of chips here. They all have gold on them or in them of some form. Now, I told Johnny up front, just so nobody thinks I'm cheating him, I told him that he could take these chips as they are and sell them on places like eBay for a whole lot more than you can get from the gold content. I don't know why that is, but chips sell for a big premium over their gold content on eBay. So he could take these 7+ kilos of chips put them on eBay, and probably walk away with more money than he's going to get from processing them and recovering the gold and silver from them, not to mention all the work and chemicals I'm going to have to put into doing it. But Johnny says when he comes back to the U.S., he wants me to just hand him some ingots of gold and silver. He doesn't want to bother with selling them. Well, customer's always right, I guess, especially when it means I get a cut. So, all right, we'll do it his way. So, look at the different types of chips we got here. And if I dig through these boxes, I could probably find more examples than this, because there's a lot of different types of chips here. So as for the different types of chips, let's have a look at these dual inline packages first. That's what this sort of chip is called. It's called a dual inline package. It's got 2 rows of legs, one on either side. That's how it gets its name, dual inline. So we've got some with gold-plated legs, and we've got some that don't have gold-plated legs. We have some that have gold bond wires inside and some that don't. We have some where you can see into them and some where there's a Cobar lid on top. And we'll talk more about Cobar in a minute. And sometimes the Cobar is gold-plated and sometimes it's not. So we got a wide variety of chips here. So how am I going to process them? Well, in the past, what I've normally done is just crushed the chips up in one of my mining ore crushers, like the Mighty Mill, and then treated the whole thing with nitric acid to get rid of the base metals, and then went to Aqua Regia. I think I've got too much for that, especially we're going to have a lot of these Cobar lids, especially when we get over into these bigger chips over here with big Cobar lids, and there's a whole lot of them with Cobar lids. Yeah, I think that's probably not going to work. I have a new supplier for nitric acid. So I've got a lot of nitric acid and I can get more cheap. I'll put a link to my nitric acid buying video in the upper right. You can check that out if you like. But still, I think using nitric acid to dissolve all this Cobar, and Cobar is an interesting metal. Why do they use Cobar on the lids on IC chips? It's a special alloy that's formulated to have the exact same coefficient of thermal expansion as ceramic or glass. So you can bond it to ceramic or glass, and it will expand and contract at the same rate as the ceramic or glass, and it won't crack. It won't debond, it won't crack the substrate or anything like that. So that's why they use Cobar. So what's Cobar made of? It's about 53% iron, 29% nickel, and 17% cobalt, and 1% other stuff. And it takes a lot of nitric acid to dissolve Cobar. Then we've got the legs on the IC chips, which some of them are gold-plated and some are not. And the lead frame material they use for the legs on the chips and the internal framework is an alloy called Alloy 42, which is 58% iron and 42% nickel. And again, it takes a lot of nitric acid to dissolve that stuff. So I think I'm going to have to come up with a better way to do this than just dissolving all of this base metal in nitric acid. All these chips also have legs on them, which are full of base metal. Possibly steel, copper, bronze, whatever, and just gold-plated. This one's got a zillion little legs on it. So that's more base metal that would need to be dissolved to get the gold plating off. And I think I'm just going to have to come up with a better way to do it than dissolving it all in nitric acid. So in case you haven't figured it out, the first part of this video is kind of a brainstorming session to figure out how I'm going to process these things. I think my usual method of just crushing them and dissolving it all in nitric acid, then going to Aqua Regia is just out the window. I don't think it's going to work. So I think what I'm going to have to do instead is crush them, at least to some extent, because I want the fine gold bond wires. A lot of these are going to have fine gold bond wires inside them. I know this one does. I can see them. This one doesn't. Those bond wires might be aluminum or another alloy, or maybe even white gold, for all I know. So I'm going to have to crush them to get to the gold bond wires. And then what I need to do is I need to separate everything that's bigger than the bond wires. So the bond wires are really, really tiny. They're very small diameter and they're very short, and I can sieve them out of the crushed material. Okay? And then catch the bigger stuff, which is going to be the Cobar lids, a lot of the legs, maybe, and the lead frame material on these. Catch that on the sieve, and then process that stuff separately. So the stuff, the bond wires being almost pure gold, I can take them straight to Aqua Regia to get that stuff. But what am I going to do with the rest of this stuff if I'm not going to dissolve it in nitric acid first and get rid of the base metals? Well, I guess maybe we'll have to try reverse electrolysis to get the gold off of all these Covar lids, off of all of the lead frames and legs on these things. That's my best guess on how I'm going to process this stuff. So I think we'll try a small scale test run and see how it goes. And if that works good, we'll scale it up and see if we can process all of this stuff eventually for Johnny. And there's a lot of it to process. It's going to take me a while. But yeah, I think we're going to try a small scale test run. So I'm most familiar with processing the dual inline packages. So maybe we'll concentrate on those to start with and see how that goes. And then start integrating these bigger packages over time. Because there's a lot of dual inline packages here. There's just a crap ton of them. So now that I have a game plan, whether it works or not, I don't know. You know, they say that no battle plan survives first contact with the enemy. So we'll see how this goes. I may have to make adjustments on the fly and change things up as we go if I hit problems. But we'll give it a shot and see how it goes. So let me get set up for dealing with some of these dual inline packages. I'll set aside a batch as a test run, and we'll get started working on them. Alrighty, I've pulled out a pretty good mix of chips here for my initial testing. By no means the bulk of it, but it's a good, I think, initial test run. I've got a good mix of 16, 24, 28, 40 pin IC chips here, all dual inline packages. We're going to stick with dual inline packages, like I said. Some have gold-plated Covar lids, some don't. Some of the window chips are EPROMs. I can see have gold bond wires in them. A few do not. So, yeah, it's a good mix. Now, I said earlier that no battle plan survives first contact with the enemy. So while I'm sorting through these chips I see, I have a bunch of dual inline chips over here and in there that do not have gold-plated legs on them. So I'm not sure I want to mix them. I think I'm going to have to sort into chips that have gold-plated legs and chips that don't. Because we're going to want to try and get the gold off the legs on these chips. But, well, if there's no gold on them, I don't think I want to run them through the reverse electrolysis process. Because I don't know what will happen. So I'm probably going to have to sort further into chips with gold legs. All these have gold legs. And chips that don't. And then once I crush these, I'll probably pull out the Covar lids that don't have gold on them, unless there's gold on the other side, which there might very well be. But if there is no gold on these Covar lids at all, I will pull them out and only run the ones with gold on the lids through the reverse electrolysis system. Okay. So let's see just how much I've got here. Get them all in this container and weigh them up for this initial test. We'll see just how much material we're working with here. Yeah, I want to prototype everything on a fairly small batch. Whoops, one went on the ground. I got to pick that up before going big time. Actually, two went on the ground. So there we are, if you can read that, 621 grams in this initial small scale test. So I think my next step is to crush these and then start screening it. Remember, the gold bond wires are very small and very short, so they should go through a small screen without too much trouble. But the legs, the internal lead frames, the cobar lids should stay on top of a fine screen, so we can set those aside for processing in the reverse electrolysis cell. Okay, so let me clean up my bench over here, put this rest of this stuff away, and we will start crushing chips. Alrighty, I am set up for crushing chips. I've got my mighty mill. I've got my dust mask, because this is going to produce a lot of fine ceramic dust, which I don't want to breathe. Got the chips I want to crush. I got a gold pan I can dump the stuff into until I can get around to sifting and sorting this stuff. It's just a receptacle. Now the mighty mill, if you've watched my channel, you know the mighty mill has been the star of many a video. It's an ore crusher, a handheld ore crusher. It's powered by an angle grinder, in this case a Ryobi battery-powered angle grinder. I can use it in the field. I've used it for its intended purpose, which is crushing and sampling gold ore in the field. I have videos on that. But I also find it works great for e-waste, like this stuff. Now, the guy who makes the mighty mills makes them in batches and sells them on eBay. At least he used to. The last couple of times I've checked his eBay page, there's been nothing. He hasn't had any mighty mills on there. He hasn't had any accessories for the mighty mill on there. He hasn't anything. You know, nothing staying. I don't know if he's gone out of business, stopped making them, died, or maybe he's gone big time and he has his own website. I will do some research on this, and if he's still around, I'll put a link in the video description to where you can get your own mighty mill, because let me tell you, I love my mighty mill. I'm glad I got one. So anyway, how does it work? Well, of course, we've got the angle grinder. Inside here, there's some hardened steel shackles that spin insanely fast. And anything I put down the throat of this thing is going to get pulverized. I mean, this will pulverize the hardest rock. It's not going to have too much trouble with these IC chips over here, I don't think, unless I overload it, which I'm going to try not to do. But a lot of these chips are stuck together, so we're going to get 2 or 3 at a time in there. We'll see how many I can put in before it chokes, but I'm going to try not to choke it. So anyway, here we go. Let's see what happens. Let's see if this stuff is pulverized enough or if I need to run it a little while longer. Oh, I'd say it's pulverized enough. Oh, yeah. Let me zoom in on that for you. Oh, yeah. I would say we are pulverized enough. Here's the cobar lids. Fine ceramic. I see the legs in there. I don't see gold bond wires, but they're pretty small. I'd probably need to take my loupe to it to find them. But this is good. I can run this stuff through a sieve, and the finer stuff containing the bond wires will go through, and the bigger stuff like the cobar lids will stay on top. So perfect. One thing I am a little concerned about is the cobar lids have kind of gotten beaten up and folded over. So I don't know how well they're going to go through the reverse electrolysis, and I'll have to pull out the ones that don't have any gold plating on them. So maybe I don't need to run them quite as long so that the lids don't get quite as beat up. I'll try that. Let me put some more in, and I won't run them quite so long this time, and we'll see what we got. There's a little bit of gold that escaped the gold pan. I'll throw that back in there. Let's see what this looks like. That might be a little better. Run for a few seconds less. Cobar lids are still kind of beat up, but less so, but the ceramic's still pretty well pulverized. The legs are all loose. So I think that's going to work. I'll just run it for a few seconds less and see how it all goes here. Okay, let's see how that was after running for a few seconds less than before. Oh yeah, that's nice. That I like. The ceramic is still well pulverized. The Kovar lids are not nearly as beat up. The legs are still all separated. I think that's going to work fine. So now I know exactly what I need to do. Just won't run it quite so long so that the Kovar lids don't get so beat up. But the ceramic is still pulverized enough that I think I can separate the legs and the bond wires from it. Yeah, it only takes a few seconds. Oh yeah, that's just about perfect. Couldn't ask for much better than that. Okay, good. So, I'll crush up the rest of these chips. Heck, I've done probably a third of them already. So this isn't going to take much longer. Then we'll get to sieving and sorting. So I'll be back when I'm done. Alrighty, the Mighty Mill has done its usual exemplary job of crushing this stuff up. I think this crush is going to work pretty darn good. So I hope the guy who makes these is still in business. I really hope so. Like I said, I'll do some research, and if I find him, I'll put a link down in the video description. Anyway, let me get some sieves out, and we'll start sieving this stuff into different fractions. Alrighty, I've got a bunch of my sieves out, or as miners call them, classifiers, and another gold pan. So what I want to do is I want to sieve all this stuff through this stack of sieves. On top I got a 1/4 inch or 4 to the inch sieve. Down here there's a 10 to the inch sieve. And down here is a 16 to the inch sieve. And as I sieve this stuff out, different stuff's going to get caught on different sieves. I'm thinking most of the Kovar lids are going to get caught up top. And then the legs from the chips are probably going to get caught on this one and this one. Only the finest dust is going to make it through to the pan. And that should have all of the bond wires in it, the gold bond wires. And I could further sift that stuff. I've got a 40 to the inch sieve here. Bond wires should go through that too. So we'll see about that later. But let me start sieving this stuff. Dump it all in here. Some shakes. Yeah, look at that. On top, Kovar lids. All right, let me just dump those right off in there. I'll sort those by whether they're gold plated or not. That one's pretty mangled and stuck in there. There we go. Okay. And just as I thought, there's a lot of legs on here and some of the smaller lids that were beat up enough to make it through. I can pull those out. Some of those 16-pin chips had pretty small Kovar lids on them. So I can pull those out. And then down here, we've got a lot of gold-plated legs. And down here, we've got a lot of fine dust, which should have the bond wires in it. In fact, I see some fine gold in there. I'll try and give you a close-up look at that. Let me try something else here. I want to try and further separate the legs from the ceramic. Oh, look at that. Look at that, how well that works with that magnet. I got to get a container to put this stuff in. But yeah, that's going to make life easy right there. If I could separate the legs from the ceramic that easy. These are probably made out of that alloy 42 because they are attracted to the magnet. All right. Being an old-time gold prospector and miner, I have all this equipment. It comes in very handy for processing e-waste as well. Yes, indeed. Check this larger fraction. Oh, yeah. This is going to make life very easy because I'm going to get rid of the bulk of the ceramic here and not have to deal with it. Oh, yeah. Life is good. Do the Kovar lids stick? Yes, they do. The Kovar lids stick too. But we're going to run them for the most part through the reverse electrolysis. So, and these legs too. We're going to run through the reverse electrolysis. So it doesn't really matter if they are, you know, steel, Kovar, whatever they are. All right. So I will probably go after this a little bit more. I see a few gold legs stuck in the mesh of the screen. And then let's go down here. This fine stuff. Yeah. Yeah. So there's a lot of fine pieces of the legs that made it through. Mighty Mill beat up the legs enough that there were a lot of pieces of them that made it through. But, you know, if I drop them and pick them up a couple of times with the magnet, I can see that the stuff is gold plated. So, all right. Now, the gold bond wires should still be in here. They are not going to be attracted to the magnet. So, what I will likely do is further sift this stuff through the finer screen and see if we can see any gold bond wires. I'll need another container, though, before I do any more sifting. So let me find one. All right, let me run this finest fraction through this 40 to the inch screen. See if we can see bond wires in what comes through. Ought to be able to. Might have to hunt for them a bit, but I'll bet they're there. That is some super fine stuff there. Let me hunt around in it and see if I can find some bond wires to show you. Might help if I panned this stuff out or ran it through a blue bowl, one or the other. Perfectly honest, I don't see anything, but I know they're there. So, most of the bond wires should be in this. Actually, I did see the glint of gold, but it disappeared as soon as I touched it. Yeah, there's bond wires in there. They're just hard to see. But I do see another problem. And this I probably can get you some close-up pictures of. A lot of the ceramic debris in here, and in here, and in here, has gold on it. So that's going to be a problem. I was hoping to just process the Kovar lids and the legs through reverse electrolysis and then just treat this stuff with Aqua Regia to get the gold out of it. But I think I'm probably going to have to treat all of the ceramic stuff with Aqua Regia to be sure of getting the gold out of it. Let me show you what I'm talking about. A lot of these pieces of ceramic have some gold flashing on them, probably to get other stuff to solder to them. Let me show you. Yeah, there's some gold legs stuck in the mesh of the screen, but look, there's ceramic with gold on it too. It's all over the place in there. So to extract all of the gold from these chips, I'm going to have to soak all of this ceramic in Aqua Regia. So So that's an added complication. Again, my battle plan has not survived first contact with the enemy. So I'm going to have to soak all of this ceramic stuff, not just the finest stuff. I'm going to soak all of it in Aqua Regia. But I'll probably do the coarser stuff by itself. Aqua Regia will work better on this stuff because it's coarse. The gold bond wires hiding in there, under all that ceramic, they're going to be a little harder for the Aqua Regia to get to. I may have to reduce the amount of ceramic dust here. I'll probably just do a little quick panning on it to reduce the amount of dust and expose the gold. Yeah, I'm going to give this stuff a quick pan just to reduce the amount of ceramic that's there that I have to deal with. I need some jet dry. Stuff's floating. That's not good. Put a little in here, a little in here. Oh, look at the difference it makes as soon as it goes in. Yeah. Reduces the surface tension of the water. Stuff doesn't want to float then. Get rid of the super fine stuff and start panning down the bigger stuff here. Now some of you are asking, why don't I just add this stuff in with the bigger ceramic chips? Well, if I add all this fine stuff in there, the Aqua Regia is not going to be able to circulate between the pieces. Everything's going to get all plugged up, and I'd have to constantly stir it. And right now I don't have a stir plate, so I'm going to pan this down so that there's less material here to get in the way of treating this stuff with Aqua Regia. So I'm starting to see how this is going to work moving forward. I'm going to wind up with 4 fractions. The Kovar lids, which I still need to sort, those with gold plating and those without. The gold-plated legs, the gold-plated ceramic bits, and then the super fine stuff that's going to have the gold bond wires in it. So I'm going to have 4 different fractions I'm going to have to deal with. Now, 2 of those fractions I think can go through reverse electrolysis. That'll be the gold-plated Kovar lids and the gold-plated legs. And the rest of this stuff I'm just going to have to treat with Aqua Regia to get the rest of the gold out of it. This stuff's too small to sit on the reverse electrolysis grid, and certainly the gold bond wires are too small for that. All right. Pan this down a little bit more, and then we'll see if we can see the gold bond wires better. I know there's a lot of gold in here. It's just hiding beneath all that fine ceramic dust. Let's get rid of a little bit more of it, and then I'll walk back the dust, and hopefully the gold will stay in the lip of the pan. Okay, let's see if we can find our gold. I know it's here. Ceramic dust is heavy though. Super heavy stuff. Little harder than normal gold panning. Oh yeah, I'm starting to see the gold. Let me pan this back a little bit more and I'll give you a close-up look at it with the phone. Alright, I took it out in the sun where there's a little more light. I can keep the focus. There's a lot of gold. You know, there's a lot more of it under this purple ceramic dust, but there's a lot of gold. A lot of gold in this pan. So I'm just going to dump all of this stuff into a beaker and we'll process it through Aqua Regia to get the gold out of it. Alright, I'm going to wash this stuff directly into a beaker. It didn't look like there was a lot of gold there, but I guarantee there is. You know, gold plating, which is what we've got on the Kovar lids and on the legs, is really, really thin. I mean, even with this stuff from the 1970s, which was thicker than what they do today, it's still pretty darn thin. But the bond wires, I mean, they're actual hunks of wire, even though they're short and they're small in diameter. I'm sure their diameter is bigger than the thickness of the plating on stuff. So there's actually a fairly significant amount of gold in this beaker. And we're going to go after that first. I'll hit this with Aqua Regia. And then after we extract the gold from this with Aqua Regia, I'll put this stuff in a beaker and we'll pour the Aqua Regia from this into that beaker, refresh it so it's a little stronger, and we will extract all the gold from this stuff. Then we've got this stuff and this stuff. I still need to sort out the Kovar lids here, the gold-plated from the non-gold-plated. But then all this stuff's going to go through the reverse electrolysis cell. So that's my game plan. My battle strategy has changed a little bit. Got to roll with the punches. And yeah, so we got 4 different fractions we need to treat here, and these 2 are going to go together through the reverse electrolysis cell. These 2 are going to go to Aqua Regia route. And then whatever gold we get from the reverse electrolysis cell will dissolve in Aqua Regia 2. And then we'll drop it all out and see how much gold we got from these chips all together. All right, so all that idle swirling of this beaker on the bench was not for nothing. You see that area where the color's different and the texture's different? I've sorted all the little bond wires into that area. That's all gold in there. That's what you're seeing. All right, let me get this in the fume hood and we'll get some Aqua Regia on it and start recovering that gold in there. Alrighty, let's get some Aqua Regia on this fine stuff and get that gold in there dissolved. I'm going to use more muriatic acid than I normally would for this amount of gold, and more nitric acid than I normally would, because we're going to reuse this Aqua Regia on the other ceramics. So once this has done its thing over here, we'll pour it off into another beaker with that coarser ceramic in it. So I'm not going to worry about overnoxing it. Put a goodly amount of nitric acid in there. That's about 8 milliliters. That might be sufficient. I see bubbling already. I don't know if that's showing up, but we got bubbling going on already over there. I have not even stirred it up yet. There's no heat on it. Put a little bit of heat to it. Stir it up. Yeah, we got bubbling. Gold will go into solution in stone cold Aqua Regia. And those bond wires are pretty much pure gold. So we've already got a reaction going. So once this heats up a little bit, I'm sure the reaction is going to pick up, although it's bubbling. I hope you can see that. And I will stir it from time to time, because even though there's not a lot of that ceramic powder debris in there, there probably is enough to prevent everything from getting in contact with the acid. So I will stir it from time to time. Oh yeah, look at the reaction we're getting. Nice. Nice. There may be more gold in there than I thought there was. All right, so we'll just let that go. And I will start putting together a apparatus for reverse electroplating of gold-plated stuff. And we'll get that gold plating off too. Alrighty, so here's what I propose to use as my sulfuric acid reverse electrolysis cell here. I've got a little basket I've made out of some fine copper mesh. Thank you, Jim, for giving me that a while back. I'm finally getting around to using it. And I've got a lead electrode here. I know I have some sheet lead around somewhere, but I couldn't find it, so I stole one of the soft jaws off my bench vise. I'll make another one when I find my sheet lead. So the lead will become the cathode, or the negative electrode of the cell. The copper basket here will become the anode, or positive connection to the cell. I will fill this up, not all the way, but just so the stuff in the basket will be submerged in sulfuric acid. And when I put power to it using a battery charger, I should be able to strip all of the gold plating off of this stuff. Now, there is not much gold plating here. We've got some Cobar lids here. We've got some legs in here. Okay, so there's probably not going to be enough gold coming out of this cell with this small test run to bother trying to recover it. What I will probably do is save the acid and reuse it down the road when I'm doing the rest of the Johnny's IC chips, and let the amount of gold build up in the acid until it's worth recovering. So we'll probably just in this video be recovering the gold from the bond wires and the stuff that's on the ceramics over here in the fume hood. But I really honestly believe that's going to be the bulk of the gold. We're just going to do this other stuff for completeness, and just so don't want to let any of it go away, but I don't want to waste a ton of chemicals to recover just a tiny little bit of gold. If I can use the sulfuric acid stripping cell, I think this will be more efficient. And the purpose of the second Corningware dish is to just contain any splashes, drips, whatever, of acid, keep it from getting all over my workbench. So that's why we're doing this. I may actually move this whole thing inside the fume hood if it starts producing especially obnoxious fumes. Some people say it does, other people don't complain about it, so I don't know. I have never used one before, so we'll see how it goes. If it starts producing a lot of sulfur dioxide gas, I'll move it into the fume hood and run it in there. But probably in the open air with a fan at my back, I think I'll be okay. Okay, it's been maybe 15 minutes. The bubbling really picked up there for a while, and look, the liquid has turned green. Probably nickel and iron, I would think. Those legs on those chips underneath the gold plating were made of alloy 42. So, yeah, the Mighty Mill probably knocked enough alloy 42 off the legs to make it through the fine mesh screen. So, yeah, I think we're getting some nickel and iron in there coloring this. But as soon as we don't see any more reaction, a little bit of orange-brown fumage in there, as soon as we don't see any more reaction, we'll do a stannous chloride test on it and make sure we're actually getting gold in solution. I know that the acid's going to attack the base metals first because they're much more reactive. So we shall have to wait until the reaction is done and then give it a check. Okay, it's been another 25 minutes or half an hour, and this reaction seems to have calmed down a lot. Let's do a stannous chloride test on it and see what we've got here. Looks more yellow than green now. I'll take that as a good sign. Let's see what we got here. Boom! Oh yeah, we got gold. We got gold in solution. Okay. Excellent, excellent, excellent. All right, I'm going to let that continue to react because there is still some bubbling going on. Make sure we get all that gold in solution. Then we'll transfer that liquid over to another beaker with the rest of the ceramic stuff in it. And we'll get that stuff chewing on the gold stuck on those ceramics. All right, so the reaction has stopped. So I think we've got a lot of gold in solution here. Stannous chloride test is quite dark. So what I'm going to do now is I'm going to take the liquid off of this stuff and I'm going to dump it on this stuff so we can keep the good times rolling. The liquid's a little bit warm, so yeah, see an immediate reaction in there. Okay, so what am I going to do with this stuff? Well, I'm going to do a second extraction on it. I'm going to put some more hydrochloric acid on it. Not quite as much as last time. And some more nitric acid. I'm going to do a second extraction on it just to make sure I got all the gold out of it. Not quite as much nitric acid this time either. And then when it looks like this stuff's done reacting, which again, it looks like maybe we've got a little bit of a reaction going on in there, so maybe still a little bit of gold in there. I wouldn't be surprised because there's a lot of base metal in there and it always gets in the way of dissolving the gold. We've got the same problem over here. This is going to give us an initial extraction, but I'm going to refresh that. I'm going to put a little bit more hydrochloric acid and nitric acid in it. Starting with the nitric acid, since I've got it in my hand here. Put a little bit more in it. Maybe more than a little bit. It's about 4 milliliters. A little bit more muriatic acid on it. So we got some fresh reactants in there to deal with that stuff. Definitely getting a little bit of bubbling over here, but nothing serious. I think we probably got most of the gold, the vast bulk of it out the first time, but might as well be thorough. Okay, got the heat up on this stuff, but it's already bubbling pretty good because the liquid was good and warm that went in there. So let that do its thing. I'll stir it regularly. I'll stir this regularly. And in a little while, I'll dump this liquid off in there and rinse the leftover debris in the bottom a couple of times and dump the liquid from the rinsing in there. Then we'll have all the gold from the ultra-fine stuff that had the bond wires in it and the coarser ceramic stuff that had gold stuck on it. We'll have all that gold in solution. So just gonna let it do its thing for a while. Everything's going pretty good, actually. I'm pretty happy. All right, well, it's late in the day, and I'm gonna have to head into the house here shortly. So I'm gonna leave this cooking for now. I'll come out later tonight and shut everything down and let it cool off. And then we'll pick up tomorrow. And tomorrow, I should be able to combine all this stuff together. And the first thing in the morning, I want to set up the sulfuric acid stripping cell and get the gold plating off of the Kovar lids. So I'm going to end this video here. So subscribe to see part 2 and see how much gold we get out of these chips. If you guys found this video at all interesting, educational, informative, inspirational, whatever, give it a like, give it a thumbs up, and I'll see you in the next video. Thanks a lot for watching this one. Bye.